All right, guys, today we're going to talk about domain and range. Domain and range are the possible inputs and the possible outputs of a function. We're going to look at linear, quadratic, and exponential, but right now I want to talk about quadratic. Your x values are your horizontal movement. So if you watch Ada and Isaac, as they move, they're kind of moving in a U shape, especially Ada and the empty swing. They're moving in a U shape. Your horizontal movement, your x values are how far out does she go, how far back does she go. That's her domain. Her range is her vertical movement. Think of the y-axis. So for her, her vertical movement is how high does she go, how high does Isaac go, and how low does she go. The lowest point when she's closest to the ground would be the bottom of her range. We're going to look at other examples in a more mathematical way, but for now, let's go ahead and start the notes. All right, video 3. What about your normal lines and parabolas and exponential curves? I promise this one's going to be less than 10 minutes. Promise, promise, promise. Okay, so I have great news. Math is all about patterns. I tell my students this all the time. You're looking for patterns. Our 3 functions, linear, quadratic, and exponential, have awesome patterns that makes this unit so much easier than it would be otherwise. Domain and range especially. So let's look at linear. An unbound linear, meaning there's no restrictions. We're not talking about real life. We're talking about just a line that you've plotted on the coordinate plane with arrows on either end, is always, always, always going to have a domain of all real numbers, and it's going to have a range of all real numbers. Remember, I told you that this symbol right here means all real numbers. A domain of all real numbers means you can plug in anything you want into that function and it will give you an answer. This is not true of every function. There are functions where if you plug in certain values, your calculator is going to give you an error. It won't work. But linear functions, you can plug in anything you want. A range of all real numbers means that if you think of enough numbers and you plug them all in, eventually you will hit every possible y value. You'll hit every number as an answer. So, this linear function, without even thinking, because it's got arrows on either end, I get to immediately say all real numbers, and move on. All right, quadratics. Quadratics also have a pattern that's going to be predictable, that you're going to be able to count on every single time. An unbound quadratic function, again, meaning it has no restrictions based on real life. If it's just a theoretical quadratic with arrows on the ends, an unbound quadratic will have a domain of all real numbers. That's nice. Same thing as what we saw before. The range is going to be restricted because remember, your range is your possible y values, and your parabolas always have that bottom value, that minimum. We call it the vertex. That is going to define what your range is. Your range is going to be based on the vertex. So the domain of all real numbers means plug in what you want. The range, or the possible outputs of a quadratic function, are going to be limited by the minimum or the maximum value, depending on whether it was reflected over. It might have a maximum. This is the point where the parabola turns around and starts going the other direction again. So we're going to look at min and max and vertex more in one of the later lessons, but we can talk about domain and range now. The domain then is all real numbers. I don't have to worry about that. I can plug in anything I want. To find the range, I'm going to say the bottom number here is -4, and then it goes up forever. Remember, we read range from bottom to top. So if the bottom number is -4, then that means my range is that y can be anything greater than or equal to -4. I've got the equal to because the vertex does hit -4 there. It includes -4 and then goes up. It's up at positive infinity. It goes down, 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 down until it hits -4, and then it turns around and starts rising again. Sometimes you'll also see this written with your y in the middle, and we say it starts at -4 and includes -4, and then it goes up to positive infinity. But those two things mean the same thing. This is saying that y can be anything between -4 and infinity. This is saying that y can be anything greater than -4. So whichever way you prefer to write that is fine. If you were going to use your other notation, then you would have a bracket here and a parentheses here. All right, so let's talk about exponential then. An unbound exponential function will have a domain of all real numbers. The range this time is also restricted. The range is going to depend on your asymptote. Again, I'm going to cover that in more detail later. But remember, I think we've discussed before that the asymptote is kind of that line that the exponential function kind of gets close to but never ever touches. So the domain of all exponential functions is all real numbers. That means every x is a possibility. The range is restricted because these functions have that line that they can't cross. It's called an asymptote, and it changes for each function. So it's going to change. Let's look at the answers to this then. The domain of this exponential, I can plug in anything. It's got an arrow going here. It's got an arrow going here. That means I can plug in any domain. So my domain then is all real numbers. So I can say from negative infinity to positive infinity. Or I can write my little r. The range, well, let's look at this. This says it's approaching this line y equals 2. It gets closer and closer to it, but never actually touches it. That means that this y value is everything greater than 2. I do not put the equal to because it's never ever gonna touch. They cannot cross. So you're going to have y is greater than 2. You could also write that as y less than 2 to positive infinity. You would have no equal to's. It will never equal 2. It will never equal positive infinity. And then it would be 2 positive infinity if you were using your parentheses. That's it. That's all it is. And these are great patterns, and they make answering these questions so easy because your domain, that should be easy points every single time, all real numbers. For all of these functions, unless it's a word problem or we give you specific restrictions, the domain is all real numbers for the whole course. The range, that changes a bit, but the more you see, the more you kind of notice those patterns, and it makes it a bit easier. You guys go ahead and try these U-tries, check your answers. Yay for a shorter video. I'll see you on the other side. Isaac wanted me to talk about him as well. He's not moving in a quadratic motion as much as Ada is, but he's still going really high and really low. Aren't you, Isaac?
Yeah, and I'm going so fast.